Stoichiometry, the calculation of products and reactants. I have prepared 6 problems, and at the end of the video, each will be listed out so you can try them on your own. First question, what is the mass of 0.5 moles of sodium chloride, NaCl? So we have the moles, and we're trying to find the mass. So according to this chart, we multiply by the molar mass to find the mass. So to find the molar mass, we take the atomic masses of both Na and Cl, and we add them together. And by the way, the atomic masses for each element are found in the periodic table. Now that we have our molar mass, we can find the mass. So we do our 0.5 moles multiplied by the molar mass to get the mass. And 29.22 is our answer. Question 2 asks, how many moles are in 88 grams of carbon dioxide? So we have our mass, and we divide by molar mass to get the moles. So to find carbon dioxide's molar mass, we take carbon's atomic number added with oxygen's atomic number, and we add them. However, oxygen has 2, right? So we have to multiply it by 2, and we add them. So this is our molar mass, and we have to take our mass divided by our molar mass to get the moles. So 88 grams divided by 44.01 grams per mole. And our answer is 2 moles. Question 3. How many molecules are in 1.5 moles of water, H2O? So we're going from moles to molecules. And on here, if we want to go from moles to molecules, we multiply by Avogadro's number. Okay, so we start out with our 1.5 moles, and then we multiply by Avogadro's number. Plug this in your calculator, and you get 9.03 times 10 to the 23rd molecules. Now for the fourth question. You have 3.01 times 10 to the 23rd atoms of helium. How many moles is this? So we have our atoms, and we're trying to find our moles. And if we look on the chart, if we want to go from atoms to moles, we divide by Avogadro's number. So let's take our molecules / atoms, and we divide by Avogadro's number to get the moles. Did you get 0.5 moles of helium? Now question 5 and 6 are harder. How many molecules are in 10 grams of methane? So we have our mass, and we're trying to get to molecules. So we have to take our mass, divide it by the molar mass to get the moles, and then multiply by Avogadro's number to get the molecules. So mass to moles, we need to divide by the molar mass. So let's find the molar mass of CH4. So C is 12.01 atomic mass, and then H is 1.01 atomic mass, but we have 4 H's, so we do multiplied by 4. Now we have the molar mass. So we do our mass, 10 grams, divided by our molar mass, 16.05 grams per mole. So now we have our moles. And to get from moles to molecules, we multiply by Avogadro's number. So our answer is 3.75 times 10 to the 23rd molecules. This was a heavy problem. We'll do one more similar to this. Question 6 asks, what is the mass of 1.04 times 10 to the 24th molecules of oxygen gas? In this question, we're going from molecules to mass. So we take our molecules, divide it by Avogadro's number to get the moles, and then multiply it by the molar mass to get the mass. So let's take our molecules and divide it by Avogadro's number to get the moles. Then to get from moles to mass, we multiply by the molar mass. So we take our 2 moles, and we have to multiply it by the molar mass of oxygen gas. So to find the molar mass of oxygen gas, we take oxygen's atomic mass, which is 16, and we multiply it by 2 because we have 2 oxygens. Moles to mass, we multiply by the molar mass, so 2 times 32 equals 64. So our answer is 64 grams of O2.